Oh, good to see you there. Checking out our project right here? It's a pretty sweet project. I know you're looking at it. Yeah. The workers in the industrial and energy field do not have a visual sensor as a way for an alert system for hazardous gases. All of it is auditory, but for us, that just doesn't seem right, as most of those workers probably wear ear protection. So we wanted to do a visual thing, as well as making a cheaper solution to our problem. We have a multi-gas sensor. Right now on the market, that's $440. It took us $56.69 for all of the materials. So in effect, we'll be able to drive our costs down, which is one of our biggest problems.
All right, so I'm going to be talking about the different parts that go into this product. So the first thing that the whole product is centered around is the NQ2 gas sensor. This is a gas sensor that can detect different types of LPG gases, flammable gases such as butane, propane, and it can also detect carbon monoxide, which is smoke. So this sends back an analog value to the Arduino, and in our coding, we have the analog value converted from that all the way to a ratio, and in this ratio is where we set the bounds. So per OSHA standards, our ratio is from 0.3 to 0.7, and that's a really high concentration of gases. So whenever it's a very dangerous concentration of gases, then we have this LED blinking red. We have the LED wired all the way to the front, so that whenever you have the helmet on, it's in the easy plane of sight. And then we also have a PiezoSpeaker in the back that sounds an alarm whenever it gets into a dangerous level. So there's a visual and an auditory alarm, so that both deaf and blind people could theoretically use it. And we feel the visual alarm is very important because many people in the industrial and energy field, in their job, they have to wear ear protection. So a visual aid, a visual alert is important so that they'll be able to know whenever something's going wrong. All right, so in the back here, we have the main component, is where we have all the sensors, devices, wiring in the Arduino. So basically, we have a simple PiezoSpeaker circuit and a simple RGB LED circuit wired up to the Arduino, and the whole system is powered by a 9-volt battery. And we use the battery jack from the 120 project, soldered that to a 9-volt battery connector, and that's what powers the Arduino to keep the whole system running all the time. So basically how the product works is that whenever there's a safe concentration of gas or smoke in the air, the light in the front of the LED blinks green, and there is no sound coming from the PiezoSpeaker in the back. So when our product detects a hazardous level of gases or smoke in the area around the gas sensor, this is how it reacts. The LED blinks red at the front of the hard hat, and as you can hear, the PiezoSpeaker is making an auditory alert.
So with this product, we use a lot of things we learned in the 120 series, such as things in the mechanical domain of fabricating things, such as putting the soldering together for our battery jack to our 9-volt connectors. Another one we used was electrical engineering with all of the circuitry in the back, with the RGB circuit, with the piezo circuit, with our sensor circuit. The next part is cyber engineering, coding for this to go on and off, coding for our bounds to be, for this to happen, for variables to be created, variables to be solved for. Then what our product we use for is actually a lot of things. We can have it be in the energy field, we can have it be in the chemical plants, industrial plants, places where hazardous gases are present. Carbon monoxide is very odorous and colorless, so here's a way to solve your problem.